Kia ora, welcome to video 4 in the series Agile Algebra. In this particular video, we're going to have a guest lecturer. His name is Cole Hickey. He was a former student of mine, a very bright young man, and I've previewed his answer to this problem. He does a very, very good job at explaining it using completely different techniques to how I would normally solve this problem, but he goes on to explain the reasons for why he's done that. Hopefully you enjoy. Here is the question that you're going to be looking at. We're solving for a quantity in terms of y, essentially rearranging the equation that we have there. I encourage you to try different approaches to solving this problem. If your maths is broader, if you've learnt complex numbers before, then that's a hint as to how Cole covers this question. Like all videos, pause the video now, give it a go, and we'll see how you get on after the intro music. All the best.
Hey team, my name is Cole Hickey. I was in Mr. Walden's scholarship calculus class in 2021, and he's asked me to record my solution to a math problem. So given y is equal to that horrendous looking thing, you need to solve for e to the negative 2x. So I've decided to make my solution a bit trickier because, the standard solution is pretty boring. So I suppose we should start it off. So I've decided to go into the complex world for it. As in, I just let x equal to iw, and then substituting that in, you can use Euler's identity. So you get that thing there, and then you're able to just expand it out into cosine w plus I sine w, or cosine negative w plus I sine negative w, depending on whether it was e to the x or e to the negative x. And then going through and replacing the cosines and sines of the negative w with its respective cosine w, you get this right here. And then once again, just going through and cleaning it up a bit, you get that here, 2 cosine w over 2i sine w, and that is just negative I cotan w. And then if you want to solve for cotan w, which we want to do, we just get cotan w is equal to iy. So now we're going to look at e to the negative 2x and see if we can get it into something of that form. So first of all, once again, changing x to iw, we get e to the I in brackets negative 2w. And then, using Euler's identity again, we just get cosine negative 2w plus I sine negative 2w. And that is cosine 2w minus I sine 2w. And then you use your double angle formulas that I'm sure you've all learnt. You get e to the negative 2x is equal to 1 minus 2 sine squared w minus 2i sine w cosine w. And you're able to factor out the sine squared w, which is something we want to do, because then that frees up that last term and turns that into a cotan right there. So then, cleaning that up, we get e to the negative 2x is 1 minus 2 sine squared w in brackets 1 plus I cotan w. Turning that sine squared into a CSC, or cosec squared w, we're able to look at a trigonometric identity, and it's similar to the sine squared plus cosine squared is equal to 1. We get cosec squared is equal to 1 plus cotan squared. And now we've gotten everything, all our trigonometric terms, into a cotan, which we want because we solved cotan in terms of y. So then we're able to substitute our iy in, and luckily enough, everything becomes real again because it is a real problem. We're not actually working with complex numbers, we're just using it to solve for a real solution in a kind of tricky way. So substituting iy into every cotan, we end up getting e to the negative 2x is equal to 1 minus 2 in brackets 1 minus y over 1 minus y squared. And if you are attentive, you will see that the 1 minus y squared is just a difference of two squares. So we're able to expand that out into this. And on the top of that fraction, we have 1 minus y, and so same on the bottom. So we can just cancel it out. And if you want to do a little bit of extra working, in general, you do want to make sure that what you're cancelling can never equal 0, because if it can equal 0, you have some issues. So if you do want to check, you want to make sure that 1 minus y is never equal to 0, feel free. But I will let you know it does not equal 0 at any point. So we're able to just get rid of that. So then we get 1 minus 2 over 1 plus y. Doing your standard sort of bringing the fractions together, getting it all cleaned up and nice. We end up with y minus 1 over y plus 1. And that's our answer. I mean, in general, you probably wouldn't want to be doing this solution to a question like this, but I mean, it's an interesting way of doing it, and just considering, kind of just shows that you can solve all these problems in such a large amount of different ways. Everything is quite interconnected when it comes to algebra, calculus, just in general. There's lots of different ways to solve things. So it kind of just makes you want to see how many different ways you can do something, kind of inspires creativity, Alright, thanks for watching.